Okay, so I'm going to make a video about some questions that will be in homework 2. Um, so first of all, let's talk about composite functions. Composite is like when you are plugging a function into another function, like you're doing f of g of x or g of f of x. So there's a few like this in the homework. So I have two functions, f and g, and let's just find f of g of x and its domain. So first of all, this and this is the same thing. It's just two different notations. I like this notation a little bit better because this reminds me that I'm plugging g of x inside f of x. So what I do is I look at the formula for f of x, and the way I like to do this is I didn't write the letter x here, and I didn't write the letter x here. I wrote everything else, though. And now instead of x, what I'm going to do is I'm going to put g of x. So that means this whole thing goes here and here. So 2x plus 1 over 3x plus 1. Like that. And now, so basically this is it. This is my answer, but I would like to simplify it. One thing I don't like is a fraction inside of a fraction. So in order to simplify this, I'm going to multiply the top and the bottom by something that will basically kill all the denominators. So the denominator I see down here is 3x plus 1, and luckily that's the same thing down here, so it looks like all I need to do is multiply the top and bottom by 3x plus 1. Okay. And we want to be careful when we do this. Maybe I'll add some parentheses here. Because what I want to emphasize is when I multiply this, this has to go here and here. So for example, when I multiply this times this, we know what happens. We know that the denominator just goes away, and I just get 2x plus 1. Now, a lot of people would make the following mistake. They would say, well, this already canceled, so now I just have to write plus 1. Right? This 1, I would just write plus 1. But actually, no. This has to get multiplied here as well. So 1 times 3x plus 1 is like that. And we do the same thing on the bottom. This has to multiply here and also here. And I know this times this is just 2x plus 1. And now I do this times negative 1. Or actually, this times negative 1 would be a minus 3x minus 1. Whoops, I have an extra negative sign. Never mind. Okay. But then that's right like that. Okay? And let me just, this step will be easy. I'm just collecting some things. 5x plus 2 over negative x. I guess that's it, because the 1's cancel. And actually, okay, I thought this was the last step, but let me... I don't really like this negative sign in the bottom. I would rather put that negative sign in the front. But that's all I'll do. So this is my simplified f of g of x. And now we would like to find the domain. Now, in terms of domain restrictions, there's a few things to look out for. You can't do a logarithm of a negative number, or you can't do the logarithm of 0. You can't do a square root of a negative. You can't, if you have inverse trig functions, then you have to worry about the domain of inverse trig functions. We'll get to that later. Of course, in this example, we're not dealing with any of that. The only thing we have to worry about in this example is division, because there is some division. We have some fractions, and the one thing you're not allowed to do is divide by 0. So let's just make sure we're not dividing by 0. Here's the function we want the domain of. So I look at what we're dividing by, and I see that the bottom can't be 0, so I see right away that x cannot be 0. Now, a very common mistake is to think that we are done now, and that this is the only domain restriction. This is dangerous when you're dealing with a composite function. When you're dealing with a composite function, you have to make sure that x is in the domain of the inside. The inside function is g, so x has to be in the domain of g. Because if you think about it, what is this composite function doing? I plug x into g, and then I plug that result into f. So if I can't do the first step, then I'm in trouble. If I can't plug x into g, then I'm in trouble. So as long as I realize this will be easy. I just have to make sure that the denominator is not 0. And I can solve for this. I'll do it quickly. X cannot be negative 1/3. So in the online homework, you want to put your answer for the domain in interval notation. So basically what we just found is that x can be any real number except for this one. It can't be 0, and it also can't be negative 1/3. Actually, before I put it in interval notation, let me draw a number line, because this is where 0 is, and then negative 1/3 would be somewhere to the left. And then our domain is everything except for those two. For interval notation, this interval is the one from negative infinity to negative 1/3. This interval is negative 1/3 to 0. This interval is 0 to infinity. So that would be my answer for the domain. And by the way, this U is a union symbol. You'll see that in the book, and you'll see a lot of mathematicians use that. When you enter your answer in the online homework, you can just put a comma instead of this U. It seems to accept that. So that's how you should enter your answer. Okay. Anything more to say about that one? Now, why don't we just do the next one? So the next one is to find an inverse function. So I'm going to find g inverse of x, where I'm just going to use the same g from before. It's this g, 2x plus 1 over 3x plus 1. So here is my procedure to find the inverse of a function. I'm going to take this, I like to use the letter y. What I'm going to do is I'm going to switch the letters x and y. So it says x equals 2y plus 1 over 3y plus 1. I'm going to solve this equation for y, and then whatever I get is the inverse. So let's do that. I have to solve this for y. I don't like fractions, so I'm going to multiply both sides by 3y plus 1. Like that. I'm going to multiply this through, so 3xy plus x equals 2y plus 1. Now I'm going to get all of the y's on one side, and I'm going to get any term that doesn't have a y on the opposite side. So, and it doesn't matter what side I pick. Why don't I move all the y's to the left, and then everything that doesn't have a y, I'll move it to the right. So this 2y has to come to the left, and this x has to come to the right. So let me do these two things at once. I'm going to say 3xy minus 2y, because this turns into a negative when I move it over here. And I'm going to say that equals 1 minus x, because this x becomes negative when I move it. Okay, so now I have all the y's on the left. What I'm going to do is I'm going to factor y out. And then finally I divide by this thing. And this is the inverse. G inverse of x is 1 minus x over 3x minus 2. And that's the procedure to find the inverse. You can always do the same thing. Of course, the steps for where you solve it are always different because it's different algebra, but the procedure is always the same. You call the original, you say y equals the original function, and then you switch the letters x and y, and then you solve that for y, and whatever you get is the inverse. Okay, so this video is at 11 minutes, so I can keep going for a while. Let's find another inverse function. And like I said, the procedure is always the same, it's just the algebra that's different. So in this one, it's going to be an exponential function, but I'm going to do the same thing. Y equals, whoops, e to the 3x minus 4. Switch x equals e to the 3y minus 4, and now I have to solve for y. Now the steps to solve this for y are very different from the steps I took to solve this for y, because this is not exponential, this one is exponential. So I have to think about how you solve equations involving exponentials. If I have e to a power and I want to get this power out, like I have to solve for something, and like the thing that I have to solve for is in this power. So I kind of want to break this outside of the power. What I want to do is do the natural log of both sides. If you have the natural log of, I'll put parentheses here. If you have the natural log of e to something, basically what happens is this and this just cancel. And let me make it clear what I mean. I mean that the next step says natural log x is 3y minus 4. Like when I say these things cancel, I mean this comes down and everything else is gone. So all that's left is just 3y minus 4. Okay? Now the rest is easy. Solving for y from here is easy. I'm just going to add 4, and then I'm going to divide by 3. Maybe I'll even do that at once. So the first thing I would do is add the 4. And actually, maybe I should emphasize the parentheses. But so I was here, I added the 4 over, then I have to divide everything by 3, so I'm good. And that's the inverse. Okay. Let's do one more inverse. This one. I start the same. I switch. Now I want to solve this for y. And again, the algebra is always different. This time I have a y inside of a logarithm. So I want to get that y out of there. What I do to do that is I'm going to do e to this power and e to this power. Because what happens when I do that, I'm just going to flip the page. It's kind of like last time where this natural log and this e canceled, except last time I had a natural log on the outside and the e was on the inside. This time I've got, it's like natural log is on the inside. But nevertheless, this and this basically just go away, and the only thing that's left on the right is just 7y minus 5. So my next step says e to the x equals 7y minus 5. And now the hard part's over. Solving for y is easy from here. I'm just going to add 5 and divide by 7. And that's the inverse function. Okay. Yeah, why don't I do more? So in the online homework, there's a couple of problems where you are finding logarithms exactly. So to do something like this, it helps to remember what logarithms mean. We say log base a of b equals c. That means the same thing as the following. A to the c power equals b. This is the key to solving all of these. So why don't I call this one c? So it's like my a is 2 and my b is 4. What that means is that a to the c equals b, so 2 to the c equals 4. And now we should be able to just think of a number c that works. It helps to express everything as powers of the same number. Luckily, 4 is already a power of 2, so 2 squared. And now I just look, if I want 2 to the c to be the same as 2 to the 2, then c should just be 2, right? And yeah, let me just make it clear. That's log base 2 of 4, right? Log base 2 of 4 is c, and we just figured out that that's 2. So let me do the other one. Log base 81 of 27. So if that's c, then that means 81 to the c power equals 27. And what I said last time is it's helpful to express these as the same number, as powers of the same number. And this one, 81's it's a big number. Of course, we recognize that 81 is 9 squared. So this is a power of 9. Unfortunately, 27 isn't, I can't think of 9 to what power is 27. So maybe we should think about 3. Because 3 to the 4th, right? 3 to the 4th would be 3 times 3 times 3 times 3, which is the same as 9 times 9, which is the same as 81. 3 to the third is 27. So once you realize that, we should use threes. So I'm using parentheses here because 81 is the same as 3 to the fourth. And of course, what happens if I do a power to another power is those get multiplied. So 3 to the 4c equals 3 cubed. Once you get it like this, we're just matching the powers. Maybe I should have left myself a little bit more space, but I'll be okay. I'm matching the powers, so 4c equals 3, and then I'm basically done here. C is 3/4. And that's, just to be clear, what I just found is the log base 81 of 27. Okay, so that's how you do those. And whoops, sometimes the video goes a little bit blurry. But I just wanted to get a clear shot before I end. Okay, so this video is over 20 minutes now, so I'm going to upload it, and the rest of the examples will go in the next video.